but it's already late, so we will get started, and the recording will be shared with all of them, and whoever who's joining in the middle, we will just continue with them actually. Sure. So about me, I'll give a quick introduction before we get into the content. So I have about 12 plus years in of experience in storage infrastructure, and I've been working with EMC for about 8 years. And last 2 years I am working with Islamic Development Bank based out of Jeddah. So I have multiple certifications in EMC storage infrastructure, EMC systems, VMware certified, and couple of cloud certifications as well. So let's get started with the content itself. If everybody are fine to hear with the voice, right? I just want to make sure before. You can even comment in the chat window that I can. Okay, fine. So this will be the the agenda of this whole webinar. We will give a quick introduction to the storage domain as well, like the different components and the different areas in the storage domain and the data challenges currently we are facing in terms of data generation and other things. We'll give a quick introduction to that, and we will review the traditional block storage architecture. So which will include different components in the block storage architecture. We will not get into details of each of them. We will have a very high level explanation of what are the features and other things. This whole webinar is to introduce storage technology to people, and whoever who wants to take up more serious courses into storage technology can go ahead with that actually. And we will review the modern storage architectures and how they have evolved from the traditional block storage, and we will also review the file and object storage architectures. Finally, we will touch upon the cloud storage and the potential career opportunities in storage technology, and the ITET IT expert training, upcoming courses in the storage domain. Okay, storage systems means it's nothing like if you have experience in IT infrastructure itself, networking systems or whatever, storage systems are designed just to store your the enterprise data centrally in the data center. Whatever the data generator is, it could be file shares, user directories, application data, databases, any sort of application data, everything is going to be stored in the centralized storage actually. So typically any traditional IT infrastructure is made up of three components: compute, which is like the servers, the virtualization, the applications, everything come into the compute; the network where the different compute nodes are connected to each other; and the storage where the data itself resides. Why go for a centralized data storage systems when each server has a lot of storage these days available in terms of terabytes, or even certain servers like Blade servers have even petabytes of data available locally. The idea of centralized storage is to make sure there is high availability that is built into the systems, into the infrastructure. So in case if there is an disaster, or in case if there is a failure in terms of software or hardware, the infrastructure is resilient enough to handle the failure itself. The high availability and performance requirements are the ones which have actually driven the centralized high-end storage needs in the past. We will see how this is changing today, and how the modern storage architecture is evolving. So the whole need for data storage itself it grows year over year, not just in like, year over year, like it's not going like 5% or 10% or anything like that. So we are producing like millions and millions of terabytes of information every day. So this information, like I have made a quick graph. Like if you see, like in 1992, we were producing like 0.0011 GB of information per day actually, which is now grown, like if you can draw a graph, which is like huge difference. Like today in 2018, we are generating about like 5,000 GB of data every second. So this is like per second data generation. So 5,000 GB of data needs a place where it should be stored. So today no data is being deleted and everything is seemed to be important. So again, another infographic to emphasize the point. So we are generating like that was in GB, like that was in GB, 5,000 GB, and this is in terms of bytes actually. So we are generating 2.5 quintillion bytes of data every day, and this is just a fun fact actually. Like if you're going to store this 2.5 quintillion bytes of data into Blu-ray discs, it would, the stacked up Blu-ray disc will become like 4 Eiffel Towers put on top of one another. So what is the data generation, or what are the data generators is here? Like everybody knows that social media is the biggest data generator these days, like Facebook, WhatsApp, or whatever social media platforms that's being used, even YouTube, or everything is generating, not just YouTube, any other video hosting platform is generating data, actually generating video content or photos or any sort of this content. But this social media generated data is not really going to be stored in enterprise companies or enterprise storage. But a lot of these the modern data, the next one is big data. The big data is like analyzing the whole of this data that is being generated by social media. So what companies do these days is like they get the feel of the market, like banking institutions or like transport companies or even consumer companies. They actually try to build their own infrastructure to get the trends out of these social media platforms to fine tune their products. For example, like today we have like bots working for the Twitter or Facebook, when if anybody is having an issue, quickly a bot will get in and start answering them. So the whole of this data that is generated is being pulled by organizations. And the other important factor is the compliance requirements are increasing actually. So we had a case where one of the biggest telecommunication companies in India came to EMC to ask for a solution, just because like the government has regulated that the telecommunication companies should be storing any sort of communication or data that is flowing through them, which is readable. By the way, like WhatsApp or any other communication is, even though it is end-to-end encrypted, there is some kind of log, some kind of the communication information is stored by these telecommunication companies. So the primary objective of the telecommunication company itself is like they were not able to, while they store this data with some kind of hardware, they are not able to back it up in one day's time actually. The backup is running like for like 48 hours to 60 hours for them, and they were particularly visiting EMC to seek a solution for this. So there is no way they would be able to handle it, and EMC provided them a very customized solution just for their case, because their existing architecture was like kind of very old, and it was very difficult to provide a solution to them, but it was provided. The point here that I am emphasizing is like the requirement for storage for companies, though the enterprise data generation is growing, enter, enterprise data generation is it's going on a very more controlled manner. But all these big enterprises like banks or any big enterprises, they are now pushed into like getting all this data to do data analytics, big data, or anything to fine tune their products. uh, Sorry, I have some difficulty in going to the next slide. Okay, looks like it was stuck for whatever reasons. Okay, so the traditional core storage technologies are like block storage, which is popularly called as like the SAN storage, and then the file servers or the NAS. And recently we have like the object storage, which is uh, mainly into the cloud object kind of storage, and the purpose-built appliances which are used for different purposes, which we will review it like as part of the. Yeah, so this is the high level architecture of a typical block storage array, which this is kind of an older architecture actually, but still today this goes holds good because all the traditional old style of storage systems and storage systems still use this architecture. Maybe not in the same way, but this is more simplified architecture. The on the left side is the server itself, where the server gets access uh, to the storage using the fiber channel SAN. So the left part, the dotted lines indicate the fiber channel SAN, which is the storage area network, and the two boxes in the middle actually indicate the storage controllers. So different vendors can call it in different ways: storage processors, storage controllers, directors, anything they can call it. But typically all the vendors were having like two controllers actually. The whole idea is to just for a high availability, where each of these controllers will have identical number of ports, their memory is mirrored between them, and any access loss of one of the storage controllers or one of the fiber channel SAN or one of the front end modules or a cable or anything, the environment will function without any issues. So the whole idea is to have a high available independent fiber channel fabric which works with two different storage controllers. And in the backend, these storage controllers are connected to the disks as such, which will be like big disk shelves, which can go like 1, 2, or 3 shelves depending upon the model itself. And the backend is used to be SAS or SAS protocol. The traditional block storage features are mainly like the ones that we have indicated. Like it used to be originally a RAID based controllers, different RAID controllers. Every vendor has their own customized RAID forms, and then came the thin device and thick device, where on demand the storage is provisioned in case of a thin, and then came the tiering, where the hot data is always in the SSDs or faster performing disks, while the less access data or moved to the slower drives in the backend. So the slower drives or SATA drives, or like even like more in SATA drives or different RPM drives. So it is moved to cheaper, slower drives, and the faster or the data which is being accessed currently moves to the faster drives, which is pairing. And then snaps and clones are like taking mirrors of the LUN or the device itself and taking snapshots. And a replication is the is like mirroring your data to a different site, or to a different geographical location, or mirroring to another data center. So these are some of the traditional block storage features, which were the main selling points, or the main reasons, other than the high availability and performance, why the storage systems were like very costly and it's been used before. Yeah, so we spoke about the same thing, but this is a quick infographic which shows like these are the different types of servers which is used in a enterprise environment. All these servers are connected to the network switch, which is in the bottom, and which goes to the firewall and internet for the network communication. So all these servers are it could be physical or virtual servers, but they'll be running out of the rack or blade server. And these servers are doesn't use their own local hard disks to actually run the application, or even in SAN boot configurations it doesn't even use the local hard drives for the operating system. Everything, even the operating system and the applications, are installed on the block SAN device. So everything goes to the SAN switch and to the SAN device here. So so just to re-emphasize this point, where the connection between the servers to the SAN switch to the SAN device, there can be three type of connections here. The original and the most used is FC, which is fiber channel, and the next one is iSCSI, and then is fiber channel over Ethernet. So typically all these are like TCP IP. These three are the golden standard for the storage area network, where TCP IP is a protocol where like a TCP is the packets or the actual data which is communicating and which is going on top of an IP network. IP network is the one which which is between routing, switching, IP configurations and other things. The same way how networks work here, you can see this is SCSI over FC. SCSI is a protocol which is defined for communication between an operating system and a storage device, or between a SAN switch and a storage device. In this case, SCSI is equivalent to TCP, and SCSI is sent through three different mediums. When when SCSI is used over FC, it's called fiber channel communication, and when SCSI is used with IP network, which is the regular IP network, it is called iSCSI SAN, and the SCSI can be used with Ethernet actually. So there is a difference between FC and FCOE. FC is using the regular fiber channel switches, and FCOE is using the same fiber channel packets and the communication, except the difference is it uses the Ethernet as the transport protocol. Yeah, these are some of these block storage. We just reviewed these the block storage architecture itself. And these are some of the products, like EMC has many series of products for block, and it is EMC VNX series, VMAX, and HP has 3PAR. HP has other product lines as well. IBM has Storewise, and NetApp has their own FAS and the ONTAP series. Hitachi has their own series, and Brocade is like primarily it's not a storage. Brocade and Cisco were the major vendors for the SAN switches itself, the fiber channel, the FCOE switches. Okay, so we have reviewed the traditional architecture, the dual controller, and the other things, and now we will see what are the major drivers which are actually driving the shift in the storage architectures for the modern systems actually. So the one of the biggest changing factors is virtualization itself actually. So the traditional way of storing, the traditional way of running the applications have changed, and except for certain applications which for licensing requirements or for any special hardware requirements, rest of all the enterprise workloads are virtualized. Whichever the virtualization method it's been used, I would say like it's been a long time since I have even seen a physical server where an application is running. So the virtualization is one of the first important factors that is driving the modern architecture, and because of virtualization, the modern storage architecture is designed directly to support the virtualized environments. And the next important factor is flash, where like the traditional way of we'll see like why and how the flash is really changing the industry. So it used to be normal flash disks in normal flash arrays, and then came the all flash arrays, and now the current generation is having NVMe disk, which is like completely changing the way storage is being viewed actually. And the other most important factor is deduplication itself. Deduplication is where like when you have like in simple terms, if you have like 3 copies of the same data, or 3 copies of the, for example, if you have a file where the file is the same, but each person is storing a file with a minimal change. One person has changed A, other one is B, other one is C. The rest of the file, which can be of whatever megabytes, is the same. So deduplication. This is like you. I'm just explaining for giving an example. When deduplication is done on this, the 3 copies of the file is stored only once, and the changed blocks for this A, B, and C are just stored once actually. So anybody who wants the file is given back to them in the same form, but only the A which is changed between these 3 is picked from another location. So with deduplication, the virtual machines, let's say there are 100 virtual machines in an environment, and when there is deduplication, the 100 virtual machines are going to have, let's say, all our Windows servers or Windows, whichever version of Windows servers. So the operating system itself is common or constant between all of the servers. They may be running different applications for different purposes with different data, but the operating system itself is same. So when there is deduplication used in this such case of, we get significant savings where only 1 block is stored for each 100 of this, at least for the operating system blocks, which is definitely going to start from a particular point in disk. And the first and the most important thing which is changing the whole of industry is Hadoop, or the distributed file systems like Hadoop. So the biggest storage requirement in this world today is definitely going to be with Facebook. So Facebook users of Facebook are growing every day in millions, and every day they add new content to Facebook. And Facebook never ever deletes any data or expires, or it cannot come back and tell a user that your data is not available. So all this data that the user generates or feeds into the Facebook network is stored, and there is no way it could be like petabytes or millions of petabytes or whatever, like I don't know, the the more than petabyte or this whatever bytes, exabytes of data, millions of exabytes of data is being fed into the Facebook network, and Facebook cannot for sure use or store any enterprise systems to store the data. So Facebook or any other web scale company has a big storage problem, which initially it used to be like even Amazon was using EMC's VNX or Clarion systems when they started their cloud business in 2006-7 times. But eventually all of the big huge data storing institutions, they really moved to Hadoop or any other distribution file system based storage. So since the file system itself is really distributed, there is the requirement for enterprise storage in terms of high availability is really coming down. So there is no need for dedicated SAN network or dedicated fabrics or dual controller or anything. So we will see how this Facebook is, by the way, is using Hadoop file system based storage, which it is building on its own, and Facebook is even contributing to the Open Compute project with its internal designed storage systems. Means they are submitting architectures and others to the Open Compute project, so anybody can just for sure they're not going to expose their customizations which they are doing to the Hadoop file systems to primarily handle storage, but they are actually giving out the storage specifications so that anybody can build their own storage. Okay, so one of the factors that we spoke about in this is Flash actually. So Flash has significantly changed the modern architectures, and a lot of companies are coming to the market primarily with the help of Flash actually. And there's been new architectures which are defined with the old on top of the old traditional architectures with just Flash as the main selling point. The traditional hard disks or the physical hard disks are always used as there is an internal addressing scheme called cylinder head sector or LBA addressing. So with Flash there is no moving parts in the hard disk, and the data is like stored just as if you store it in your RAM. So the Flash based hard disks are really fast, and they are like more than like 10 to 12 times faster than the regular hard disks. So one of the reason why enterprise storage used to be very costly in those days is like to provide optimized algorithms and optimized speed with the centralized hard disk which are actually running in your data center. So with Flash into picture, the whole architecture is changing, and the systems which are designed today are actually even giving up the regular addressing schemes. We will review an architecture in the next slide which will give a better picture on this actually. and the other one is deduplication. So definitely flash is costly. Flash is much costlier than what a regular move hard disk is. So but with the deduplication into picture, um, the data itself is like the normally in enterprises, data or data storage cost is measured in per GB. Though you may be buying a big storage system for like 2 or 3 million dollars, finally the system is sold or like the bought on a scale where per GB, how many dollars per GB cost is the one which really matters to the management. So to store 1 GB in an enterprise fashion, I'm spending so much amount. And with deduplication and flash, though flash is costlier, with deduplication in picture, the per GB cost is really coming down. So even if it used to be like when if I correctly remember, it used to be even like $7,000 or like $5,000 per GB storing cost, which is really coming down with the help of flash and deduplication. So there is a whole new series of arrays that are storage arrays which are built, which are called all flash arrays, and they are really challenging the existing established vendors for business. And there is the whole industry is disrupted because of the all flash arrays itself. So this is the traditional architecture where you have a storage array software which actually runs SCSI commands, and there is SAS or SATA, and this SCSI is actually converted in this SAS or SATA is translated to have flash systems and other things. But with NVMe is like I think I don't remember the expansion, but it should be like non-volatile memory express. The idea here is like in our regular motherboards or even in the regular big storage systems, all the hard disks are connected behind the storage system using either a SAS or SATA protocols. With NVMe, the whole thing is changing. Like so, NVMe storage is actually used like in PCIe slots, where the RAM is put. Regularly in a server motherboard, there will be like multiple slots, like even like up to 64 slots, where the RAM or the memory of the server is inserted and multiplied. So NVMe is a new series of hard disks. You cannot call them hard disks. NVMe storage is directly attached to the PCIe slots of the system itself, but it is not like memory. It actually persists what it's been written, but the performance is like memory. So these protocols, SAS and SATA, are actually slow. The protocol itself it can handle only up to a certain amount of transfer size. So with NVMe, so anybody can build a system which will have like very less latency or very high performance. Means like you have your hard disk now just put inside the PCIe slot of your motherboard. So these are some of the highly most wanted brands of today actually. So some of them are like really established. The first one and the best out of this is Pure Storage. Pure Storage started some 6-7 years back. They started really disrupting the industry, and EMC. Since I was with EMC, I can there were a lot of stories where like EMC was really concerned about the growth and how people were like getting Pure Storage in their data centers. And the first three, which is here, are kind of very similar. Pure, Tegile, and Tin3. All of this are are like all flash arrays, and they have their own architectures which are tuned to use NVMe and other things. Extreme IO and Nimble storage are two other very promising all flash very good storage systems, and Extreme IO was acquired by EMC and Nimble was acquired by HP. Though they are part of their things, these are the most wanted all flash array products. The next with the hyper-converged infrastructure. So the all-flash array products are more or less similar to the traditional block storage architecture that we reviewed. The only difference is the way the storage system itself is architected or designed. So the SAN remains the same, the LAN or the fiber channel network or everything is going to be the same. And it is it is a centralized storage system which is outside of the servers. So the centralized storage system, the servers access the centralized storage system using either iSCSI SAN or using SC-SAN to get it. But internally, the system uses flash, and the architecture, the way the system is designed is different. The next biggest change that is the industry is seeing today is the hyper-converged infrastructure, and the way storage is being used and the storage arrays are designed completely changes with hyper-converged infrastructure. So the hyper-converged infrastructure is again the main driver for how the main driver for the all-flash arrays was deduplication and flash. The main driver for the hyper-converged infrastructure is the distributed file systems. Yes, definitely there is a big boost that is given by the flash, but the main driver is the distributed file systems. So we'll see some of the couple of hyper-converged infrastructure storage little bit in detail here. Hyper-converged infrastructure means literally like the components, the different components we initially spoke about: compute, storage, and network. So it used to be different systems completely. For compute, you used to have server with virtualization or physical servers. For network, it used to be routers, switches, and the other components. And for storage, it used to be different block and file storage. With converged, hyper-converged infrastructure, all of these components, like different components like storage systems or network devices or like all of that converge, and they are run in one system, which is actually not a single system, but it will be like distributed nodes. Like it could be a 5-node hyper-converged architecture system, or it could be a 100-node hyper-converged architecture system. And the beauty of this is like there are like open hyper-converged software available that you can buy your own server and install this, and you can provide enterprise grade storage or virtualization or networking. And the other advantages, like it used to be like for different systems are managed in a different way. With hyper-converged architecture, your virtualization or your compute and the storage is managed from a single console. Yes. So the hyper-converged actually started with the traditional or converged infrastructure, which is on the left side. The converged infrastructure is something. It's the traditional way of how the infrastructure worked, but the only difference is everything comes in the same rack. So if you have a particular requirement where you're going to set up a new application, or you have going to set up a new data center or something like that, so your requirement is satisfied in one single rack, where the servers are in the same rack, or your fiber channel SAN and your network switches are also on the same rack, and your storage is also on the same rack. It is just a different way of arranging the hardware. But one advantage that was provided with converged infrastructure was the single window of management, where there were some tools which was provided with which the customers were able to manage storage and virtualization from a single console. So from hyperconverged infrastructure came hyperconverged, from normal converged infrastructure came the hyperconverged infrastructure. Hyperconverged infrastructure, as we see here, there are just a bunch of nodes. So it could be 3, or it could be 30, or it could be 300 nodes here actually. And each node has its own storage, and each node can have its own SSD and the regular storage. Just a minute. Sorry. Yes. Each node has its own SSD or regular storage, and each node has its own computing power. So what this literally eliminates is this eliminates the need of a physical SAN, which means we don't want any more FC switches, and we don't want any centralized storage systems. So the servers itself do the storage function, and they also host the applications or the operating systems. And this eliminates two big costs, and it makes the architecture more simple in terms of hardware and little more complicated in terms of management and software. So the whole point, let's go. Yes. So we saw HDFS is was one of the main factors because of which the converged infrastructure really really developed as a storage platform. So initially it used to be the same way, like a little more deeper. So it should be like different applications, your database, your email servers, or your application servers, or your web servers, and they actually write to all the data, and all the data are centrally stored in a SAN or a NAS, whichever it is. With Hadoop, everything changes, and each of the node has its own data, and there is a distributed file system. This file system is actually spanning across all the nodes, and you define like how protection is handled in this file system. So if you let's say you have a 30 node cluster, and if you want to survive like a 3 node failure, and you can configure the system in such a way that your data is always having 3 copies in one of the other nodes. So even if there is a 3 node failure, the file system is running and your data is somewhere available in the distributed file system cluster. Similarly, it's not just the node, even the drive. So we can choose how to place the data actually. The protection in terms of inside the node, in terms of drives. Actually, a lot of systems, they don't even use a write controller. So everything is software defined. So the file system, the number of copies, everything is software defined. Earlier it used to be like specialized write controllers, specialized storage software and other things. But now, like with the help of software and with the help of Flash, because it's very fast, everything is software replicated. For example, like if there is, let's say, one of the biggest Google data center has completely crashed for whatever reason. So will Gmail come back and tell you that your mails are lost? Definitely not. Gmail actually replicates it even to different locations in the world actually. So somebody who's accessing Gmail from the Middle East will go to a server which is or which goes to a data center which is more near to Middle East, while somebody who's in Singapore who is accessing Gmail will have go to the data center which is near to that, and every data center is having a copy of your email, and if it is not available in permanent storage, it's going to fetch it from the near one. So all of this is being replicated at software level. So these are some of the more prominent products which in the converged infrastructure space. So VxRail is like EMCs actually. So to give a quick background on this, like actually the traditional converged infrastructure was actually started by VMware, EMC and Cisco coming together, and they formed a company called VCE, which is called VMware Cisco EMC Alliance, and they started making systems called vBlock systems, which were originally converged infrastructure, and later EMC decided to purchase all the shares and it took full control of VCE, and VxRail and vBlock systems are products of EMC actually. They are converged infrastructure, but they are heavily dependent on VMware infrastructure. Underlying, we will review the architecture in the next slide. And the other company is Nutanix. In terms of market adoption and in terms of like a more positive outlook, actually Nutanix is rated much better than VxRail. So Nutanix has its own hypervisor and it has its own architecture. Again, this architecture is designed with the distributed file system, but Nutanix is seen in a much better position in compared to VxRail, but VxRail is still EMC, Dell EMC is the leader in this space. And Cisco also now has its own HyperFlex architecture. Again, it is with compute, Cisco UCS servers, Cisco software defined networks, and Cisco's own distributed file system for storing with tiering and all the required features of a storage. And HP SimpliVity. Again, SimpliVity is a company which is actually, it was acquired by HP, and this is also hyper-converged infrastructure company. So this is a VxRail software architecture. If you see, the underlying one is the VCE branded servers, which is now the Dell branded servers. It's been shipped with Dell servers these days. And on top of this is running your ESXi or the vSphere suite of applications. And ESXi has ESXi is used to run the virtual machines, and there is vSAN from VMware which is used for the storage, and then the additional applications. So you put like 100 nodes of the servers and construct a very big cluster with the vSAN, and there is like it's not so simple to do it anyways. Like there is a lot of requirement in terms of the node availability, like how many SSDs should be there in each node, how many nodes should be there, what is the protection and other things. The configuration and the design part is like not easy. It is complicated, but it makes things very, very simple for the end user. This is Nutanix's architecture. Again, the same distributed nodes, and this controller VM is the one actually. The Nutanix has its own hypervisor layer, which is called Acropolis hypervisor, which is a hypervisor actually built on top of KVM or kernel virtual machine actually. Like Zen, like a lot of virtualization products are built on top of Zen kernel. So similarly, Acropolis is Nutanix's own homegrown hypervisor, which is built on KVM. And the controller VM is the heart of the whole storage here. The controller VM runs in every node in the cluster, and this VM is responsible for the distributed file system. With this, it controls all this controller VM actually controls all the storage in each node, and it keeps replicating, it keeps copies, it moves data between SSD to HDD, or it does all the functions what a centralized high-end enterprise storage is supposed to do. It does clones, snaps, replication, DR replication, everything. Everything is done with the controller VM. Definitely, there are more components. If we dig deep, it will be more complicated inside on how each controller VM is configured and other things. But this is beyond the scope of this webinar. Yeah. The next is the file storage. Yeah, file storage, or generally it is called as NAS. So anything, even we can have a home NAS where you put a couple of hard disks inside a small case where which runs the NAS software, and anybody in the house can access the hard disk using an IP or using an app to get the or run or connect your TVs to a centralized home NAS. So in a similar way, like in enterprise, there are a lot of requirements for NAS storage, like your file share, enterprise file shares, or some applications actually store data in NAS, and it could be your home directories, and there is a lot of applications which need NAS for their functionality. So the difference between NAS and SAN primarily is here there is no storage area network or very high-end block storage systems. In a SAN or a block storage system, all you get is a LUN. The whole purpose of a block storage system is to give you a LUN or a virtual hard disk, you can call it. You can call it as a LUN or a virtual hard disk, and that is the whole and sole purpose of a block storage array. Behind this LUN, it will do a lot of features, whatever the thin, RAID, protection, efficiency, performance, replication, snaps, clones, anything. But the only and sole and whole purpose of a block storage system is to give you a LUN. Even if it is with all flash arrays or with any array, it is going to give you one LUN. That's it. And in terms of a network storage, it is different in terms of that the storage actually given to you is not a LUN, but it is a file system in itself. For example, if you access a shared drive in your organization, you just enter you just click the mapped drive, or that just put / whatever the path is, and you get access to the files, and you use the files, copy, save, do whatever, and it is connected through network. You can access your NAS from your laptop or even from your mobile or from anywhere. But the SAN storage is designed only for servers. So to access the SAN storage, you need specialized fiber channel adapters and other things which are incorporated into only servers. And these are some of the protocols supported by even the Windows file server is a basic NAS, like NetApp NAS, Windows file server, EMC, Isilon, VNX for file. Anything is NAS, and they support major NAS system supports these four protocols. SMB is for like Windows file sharing, or it is also called as CIFS. NFS is for Linux or a Unix platform file sharing, and FTP and HTTP. These are the common protocols supported by any NAS systems. Okay, so I put this slide primarily to emphasize one thing here. Initially, we were having DAS in old days, where there is an application in a server on top of a file system, and the server had RAID controllers and different hard disks underneath of it, actually, from which the storage evolved into NAS and SAN. And now in modern architecture, we are actually going back to a DAS. Means like the storage is now the NAS or SAN portion of the storage is now coming back to the DAS mode, where all the storage is local to the server itself. Just a minute. Give me a minute. Actually, my laptop battery is running low. Give me a minute. I'll just connect. Yeah. So, sorry for that. Actually, like my laptop battery was really low. So actually, we are moving to the same old architecture where the storage is local to each of the server, but the software is now like highly sophisticated to handle storage so that the file system is actually in a distributed thing. The file system here is actually spanning across multiple nodes, so the storage is locally attached. So these are some of the NAS products which are like more, which are more prominent in the market, like EMC, Isilon. EMC used to have VNX for file or Celera series of storage, which is like now rebranded or redesigned called Unity, and NetApp has their own ONTAP filers, which is like with the ninth version now. It's like evolving and it's being added, and I think with the ninth version or eighth version they are actually moving to a distributed file system. The next is the object storage itself, like, so how block is going to give you a LUN and how file is going to give you a file system like NFS or CIFS. Object storage is primarily used for storing unstructured data. Unstructured data is stored into objects itself. For example, before we review this, like, let's yes. So for example, here if you see, like, these are two files. These are like an X-ray of a patient. So the first one is the file, which is actually which is a file itself. The file can have a limited predefined metadata which is defined by the operating system itself. So for example, if you name the file as an .gpax extension, it will show you .gpax, and the created date or the location of the file, the owner of the file, the size, and the last access date. And for certain files like image files or for video or audio files, you will see the file, if it is an video or audio file, you will be able to see the length of the video or audio also from the metadata if you select it. But it is predefined by the operating system. Anybody who want to add additional information to a file should be adding it into the file, but not to the metadata of the file. But in terms of object, an object is in object storage, objects are stored, files are stored as objects. You can call it files are stored as objects, and you are free to do add or modify anything in the file actually, data and metadata both. You can add, like, now these are the additional information that is being added: the patient name, the date of birth of a patient, injury date, and what is the additional findings and everything. So so even any photo that you upload to Facebook, or any data that is uploaded to different environments in the web scale companies, everything is stored as objects actually. So everything has an object ID. So you post a Twitter post, this Twitter post is an object, and this has an object ID, and this object has a lot of metadata which is defined by the company itself. Photos or text or post or anything is an object. And there is a lot of advantages for these companies in maintaining objects. For example, for a file is stored in a file system, and this file system is a complicated software in terms of, like, for a file system, the file system is constructed with inodes in terms of a Linux file system. This inodes, and then there is hierarchy in a file system, like, you put slash 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 slash, and there are limits where an operating system can handle in terms of the length of path or the file system names, and a lot of other complications in terms of permissions. Each file has its own permissions, different hierarchy of permissions. The upper path has a permission, the lower file has a different permission. A lot of complexities are available in file, and it is very limited in terms of metadata. So none of the going forward, like, all the modern applications will start using object storage, or will be redesigned to do object storage. So this is just to emphasize what an object is actually. Like, if anybody of you have any experience with Amazon's AWS or with Azure or anything, so the primary forms of storage which is actually provided by Azure or Amazon is, Amazon provides S3 storage service, which is actually object storage, which is used in buckets. And Azure's primary storage thing is Azure Blob Storage, which is again object storage. And this is a quick comparison between these three storage methodologies, where data is stored in objects, and each of this has a unique identifier. It will be a very long identifier, but let me see if it is available in this file. Yes, there is an object ID here. If you can notice this object ID is a very complex ID with characters and numbers. So I cannot recollect what is the standard object ID length, and this is an object ID which is unique in the whole system. So even if you name a file in a different way, or which is between different containers, the object ID is unique. So if you want to read a particular object, all you need to do is to request an object, and you can actually filter or search through the metadata. If you want to see all patients with all the objects for this patient, or like a database, you can query the metadata to get the objects. So it's not a database like rows and columns, but there is a lot of metadata available for us to fetch what we need. Yes. So primarily how object storage is accessed is with HTTP and REST API calls. Primarily there is only two commands, a get and a put. If you want to simplify it, it can be called get and put actually. And there is like softwares or clients which is designed to do this in the background. For example, if you're using Dropbox, or if you're using any other centralized cloud storage applications, or even Google Drive. So all of this is storing your file in object form. So all what you add or what you remove is actually going to the backend system in terms of a get and a put command, basically. So it boils down to just a get and put, and with a get, all your metadata or query or everything is attached in the get. uh, there seems to be an issue. Okay, let me share my screen actually. Give me a minute. Okay, can you see my screen now actually? Can somebody confirm? Because like initially the admin was actually sharing it. So
Yes, we can see you.
Okay, great. Alhamdulillah. Yeah, we just went through this how an object is stored, and these are some of the main on-premise object storage platforms. So Red Hat is Red Hat is famous Ceph storage, and Scality has a product called Ring or Ring. Yes, Scality Ring is an EMC. ECS is Elastic Cloud Storage, and Hitachi has its own Hitachi Content Platform. So these are some of the object storage products, and all of them work in the same way. Like behind the screens, they are going to use file systems, distributed file systems, or whatever. But how the storage itself is exposed to the end user or to the applications is in terms of objects. So after object storage, the other only thing which is on premise left is the purpose-built appliances. The purpose-built appliances is like virtual tape libraries, like VTLs, which are actually increasingly replacing the traditional tape libraries. So these are like block devices, but the only difference is like they will expose the block devices in terms of virtual tape. So the old applications will continue to use it in terms of virtual tapes. So they'll not feel any difference. It will just appear as if they are writing to a tape library. And the next one is storage virtualization. Storage virtualization is it's a little it's a little tricky area, because like a lot of things have changed on the other side, so that storage virtualization is now is being replaced by software defined storage, or with cloud storage and other things. But still, storage virtualization has a big place. Um, it has different components like EMC's vPlex or EMC's Viper, or these are some of the products which actually don't have a real storage in them actually. I mean, like, they don't have a hard disk or storage, but before presenting an application or device to an actual server, all this is presented to the storage virtualization device, which in turn will do more, more easy management and mirroring or whatever it want to do, and it will present a new device to the server. So this is a layer of devices which come in between the storage and the server. And then there's the replication appliances. So again, there are different vendors and different types of replication available, like people who actually like IBM or Brocade or even ActiveHue, they have like products where the IO that is going to hit to a SAN switch is split and it is sent to a remote location. So replication appliances are used only for DR kind of situations where the whole storage which is supposed to be available in the DR is replicated through and it is in sync with both. And the other one is the cloud storage gateways. Cloud storage gateways, we will review them in detail in the next coming slides actually. So the cloud storage gateway is something, it's an interface for the cloud, for example in an hybrid cloud environment. So for example in this picture, like the series 8000 hybrid storage array which is sitting here in the center, which have been, this is a storage gateway. So this is from Microsoft actually. So this is like Microsoft Store Simple Series 8000 hybrid storage array. So what it does is like basically it provides storage to the on-premise servers. So all of the storage that this array is giving to the on-premise servers in terms of capacity, let's say this array has like 2 petabytes of capacity, which is hosting all the information. And behind the scenes, this array actually moves data and it syncs to the Microsoft Azure. And seamlessly, without even the user feeling any difference, the data is actually synced to the cloud. So some of the use cases of the storage gateway is like backing up to the cloud. So currently in enterprise cloud adoption, the highest percentage of things that is moving to the cloud is the backup to the cloud. Basically the only difference is like all the locally stored data in terms of VTLs or tapes or other things are being currently synced to the cloud to reduce the storage footprint in the on-premises. And then is a hybrid cloud implementation, which we just saw. This is a hybrid cloud where you have some on-premise applications and the data is being sent to the cloud, where you can have other applications which will use the data. For example, if a bank or an organization has one website which customers access always, and it has different requirements, but it needs some data. So this only data which a web portal of the company needs can be synced to the cloud, and the remaining data is going to sit on your data center. And the portal, which is the portal application which is actually using this data, can run from a cloud, which is a typical hybrid cloud environment. So cloud storage gateways actually help in hybrid cloud implementation, and they also help in cloud as a DR solution. And there are a lot of cloud gateways actually, like the most prominent is like AWS Storage Gateway Service and Store Simple, which is like bought by Azure Microsoft, and it is now Azure Store Simple. Yeah, we've reviewed. We have come to the end of the presentation. We have reviewed the technology, the trending, the advanced architectures, and everything. And the next is the potential carriers in the storage technology. So yeah, so this is another infographic, a nice one that I found, which is like the number of emails which is being sent and received. Actually, every year the number of emails which is sent grows 5%. So in 2017 it was like 263 billion email per second, but in 2018 it is like 300 and something number of emails sent per second. So these are some of the roles which can be taken up actually. So the traditional core storage administrator or storage implementation engineer, if you are working with an OEM vendor or with an OEM partner or an architect. So this spans, this is a little wider role, and anybody who's a storage administrator is expected to be good in block storage administration, storage SAN administration, and file storage administration. Though there could be multiple vendor systems, the concepts in terms of LUN, in terms of snaps, clones, and all this we discussed in and everything. The concepts or how the features are used remain the same, except that the underlying architecture could be different. Even for the all flash arrays, these roles are the regular roles. And since now the actually the infrastructure converges now, so even the roles are converging. So the a regular SAN or storage administrator role is being now increasingly merged with the virtualization and storage administration. So instead of having a virtualization administrator and a storage administrator, companies are now preferring to recruit somebody who's like good in virtualization and knows storage, or good in storage and knows virtualization. And this applies to the hyperconverged infrastructure, because anybody who's going to manage hyperconverged infrastructure should be knowing both storage and virtualized environments. And then another a role which is always in demand, and if you have this skill, you can be sure of recruitment, is data migration. So a lot of companies which are actually, even if you are implementing a hyperconverged or all flash or a modern infrastructure, or even migrating to the cloud, all of this needs data migration from block to block, block to cloud, or anything. And it needs very, very careful design, planning, and implementation for a storage migration, data migration, and data migration experts are always in demand. Certifications as such, like all the major vendors like EMC, HP, Hitachi, IBM, NetApp have their own different paths, which starts with everybody have the same paths actually. They have a storage administrator and an implementation engineer, and in an advanced level you can be a architect in each of these storage product lines. And then for the storage area network, Cisco and Brocade have their own certification, and an additional common vendor free certification is available from SNIA. So hyperconverged products like VxRail, Cisco HyperFlex, or Nutanix also have their own paths of certifications. And we will be from ITIT, we will be covering, and there will be a lot of courses that's been planned for traditional storage administration and for hyperconverged infrastructure. And it will be good 20 to 40 hour courses, which will cover like from the basics up to very advanced level of each of the storage areas in terms of complete features, and with adequate labs and other things. And we also plan to have a data migration deep dive code, which will help, which will be kind of a workshop, which will help everybody to get good insights into how large scale data migrations are done. Yes, we are at the end of the presentation, and I'll be available for any questions. Like anybody who has questions can ask now actually. Anybody has any questions? There is noise in somebody's line actually, so nobody has questions, or like we will close it. Okay, looks like there is no questions. So thank you everybody for like patiently listening to us. Like you can even I know post it to the portal. Actually, this will be available as a recorded video, and it will be made available to all the registered participants. Thank you again. Assalamu alaikum.